Today we're going to solve for the three currents you see in the circuit. So I1, I2, I3. Some of the problems will not give you the loops. Okay, so follow the steps, no, for the mesh currents. Okay, so if you can remember the mesh analysis in the video presented, there are 5 steps, but we in here we will follow the shortcut steps. So basically around 4 steps. Okay, so we will ignore the other ideas. Okay, so we just simply follow the shortcut. So if you haven't watched the video, so I would like you to check it out. Okay, so the first step is to construct mesh currents. So in the given example here, now we already have mesh currents I1, I2, I3 with the given clockwise directions. Okay, so second, okay, so first, mesh currents assign or um, assign mesh currents. Okay, which is already done. Okay, second step is to construct KVL equations. Okay, but here in the shortcut step, we directly convert the summation of voltages into summation of the product of currents and resistances. Okay, so basically combination of KVL plus Ohm's law. Okay, okay, combination of the two. So basically we can solve it. Okay, so we have the first equation at, okay, so maybe I'll use another font here. So at mesh I1, so we have the equation -2. Why is it -2? -2 volts, no? So we started from this direction, so -2. Okay, it enters the negative, so therefore that's -2. Then plus 1 ohm. Okay, now multiplied by the current. So because this is summation of voltages, so -2 is a voltage and 1 is a resistor, so it needs to be multiplied by current. So you have I1. Now in the video it was stated that if you are in the mesh 1, I1, then I1 is always positive and then I2 is negative. Okay, why is it? Because you can imagine a positive polarity here, negative. So I2 enters to the negative while I1 enters to the positive. Okay, so and then plus minus 3 volts. Okay, you can see here. So the current enters this way already, and then you have plus 5 I1. Now there's also I3 because I3 also enters this direction but in the opposite direction of I1. So therefore this is negative I3. And then this is equal to 0. Okay. Now remember, if you are voltage sources, you don't need to multiply by current. Okay, because this follows KVL, summation of voltages is equal to 0, and this is resistor, this is current. So multiplying the two becomes a voltage. Okay, so I hope it is clear. So that's a common mistake, and remember the polarities or the negative and positive sign. So whenever it enters a positive, becomes positive, and it enters the negative, it becomes negative. So that's the first mesh, and then we have mesh number 2. Okay, so I2. So that's a reference. So making it, the reference goes like that. Okay, so we can start from 1 ohm. So 1 ohm. So 1 times I2 minus I1. Now, why is it I2 minus I1? While previously it is I1 minus I2. As I said, if you're in the mesh I2, so I2 is always positive because it's like our reference current is I2. So I1 is opposing I2, so therefore that's negative. Okay, then it goes to 6. So we have plus 6 times the current. Now there's no other current flowing 6 ohms but I2. Then plus 9. Now the current so we have I2. Then I3 is opposing I2. So therefore it's minus I3. So there's no other, so we complete the loop. So then this is equal to 0 with the principle of KVL. Then so we have the last mesh, mesh I3. You can see we can start from 5 ohms, you can start from 9 ohms or 7 ohms. It doesn't matter. Okay, we can start from 5, and we know from 5 ohms I3 and I1 flows in that direction. Okay, so you have I3 minus I1 and plus 3 volts. So you remember why is it negative? Because it opposes the direction of the reference mesh, which is I3. Then plus 3 volts, and don't multiply by I3 because it's already a voltage. Plus 9. Now this time I3 minus I2. Okay. And then plus 7. There's no other current flowing 7, which is but only I3. And this is equal to 0. So here we go. We have 3 equations, 3 unknowns. And we have this 3 equations we need to arrange. No? So we arrange this equation in terms of linear equations. No? So first we have I1. So I1, all I1s, we have 1 plus 5. So that's okay, 6. Or you might wonder, we can just write 1 plus 5. Okay, and then plus I2. Do we have I2? I2 is negative 1 here. So we have I2. 1 times negative. Okay, so this is negative 1. I3, how about I3? So you have negative 5. Okay, do we have any other constants? We have negative 2, we have negative 3, so negative 5. Then transpose to the other side becomes 5. So this one here and this one. Okay, so that's the pattern. Okay, so you can interchange actually I2, I1, I3, or whatever position you want, but make sure that the succeeding equations have the same order. Okay, so in the second equation, so we have I1 here, okay, and then I2 here. Okay, so that's, if you want I2 here, then it should be I2 here. Okay, so that's the rule in linear equation. Okay, so you will discover these things in your advanced engineering math, or yeah, algebra. Basically this is algebra. Okay, so we have I1 only negative 1, then we have I2 checking this equation, so we have 6 plus 9 plus 1. Okay, so this is 6 plus 9 plus 1. Okay, plus I3. I3 is negative 9. Do we have any constants? No. Okay, so basically what I'm doing this like I1 parenthesis this one, because I'd like you to be careful with the negative sign, because sometimes if we write this one negative I1, sometimes when we calculate this one using our calculator, sometimes we miss the negative. Then if you only miss one negative value, then your answer will be incorrect, totally incorrect. Okay, so at third equation, so we have I1 again. So we have only negative 5 plus I2. So we have negative 9 plus I3. How about I3? So we have 5 plus 9 plus 7. How about constants? So we have 3. So positive 3 here transposed to the other side becomes negative 3. So here we have 3 equations. Equation 1, sorry, maybe I'll write in another. Equation 1, we have equation 2, then equation 3. So we have 3 equations, 3 unknowns. You can solve it using whatever method you want. You can use substitution, elimination, or any numerical methods, Gaussian methods, Gauss-Seidel, direct or indirect methods. You can also use your calculator, the best way. No? You can use your calculator. So then we can solve for the third step, which is solve for currents. In this case, mesh currents. Okay, so you can use your calculator. So you have I1, I2, and then I3. Okay, now actually the last step is solve for the problem. Okay, for the problem. using the currents. As I said in the very beginning, you can solve any problem like finding the power, finding the energy. If you're given with currents and then you already have resistors, okay, given, then you can solve whatever the problem is asking. Okay, for example, the power of across 7 ohms or 9 ohms, power at 9 ohms. You simply, if you look at the power at 9 ohms, so power is regardless of the direction of the current. Okay, so as long as it is passive, no? So you can, what you can do, so you have 9 ohms here, then you have I2 minus I3. So you can write this way, I2 minus I3 squared times 9 ohms. Or you can use I3 minus I2 squared times 9. Okay? And then, so given the currents. Now, if you're looking for the current power across 7 ohms, very simple. Okay? So if the problem is asking for the power 7 ohms, you can do is I3 squared times 7. Why is it only I3? Because only current I3 passes through 7 ohms. Okay? So that's it. That's for the this example. Okay? For using mesh current or mesh analysis.